Hey there folks, Mr. G here with another educational video. This time we're going to be starting off with some fractions. So we've already done integers, adding, subtracting, multiplying, dividing, we've done some BEDMAS stuff. Now we're going to go over some basic fractions. I figured we'd start with, what is a fraction? How do we draw it? What does it represent? When we write a fraction like 1 over 4, there's a lot of different things that this can mean. Most commonly what we're talking about is that this 1 represents one piece out of a total of 4 pieces. So if we were to draw this using a picture, we could draw it using a circle. We would divide it up into 4 pieces, and if one piece is out of the 4 pieces, that means we would shade one of these pieces in. We could also draw it as a bar with 4 equal pieces and shade one of the pieces. We could also draw it as a square and divide it up into 4 even pieces and shade one of these pieces as well. All of these are different ways of drawing 1/4. Now, if you've forgotten, this top part has a special name. This is called the numerator. And the bottom here, this is called the denominator. If we took another fraction like 2 over 3 and we wanted to draw what this would look like, again, we would start with a circle and divide it into 3 even pieces. Now, my pieces aren't super even, but they're pretty close. And in this case, we would shade 2 of them in. Remember, this fraction is the number of shaded over the total number of pieces. We could also draw it as a bar here, where we've got 3 equal pieces and 2 of them are shaded in. So that's how we draw fractions. Now let's look at some basic operations with fractions. Let's say we wanted to add 2 fractions together, 3 over 8 plus 1 over 8. The best way to do this to start off with is to draw a picture. Now I've got my fraction wheels. The first one, I'm going to color in 3 of them here. And for my next one, I'm going to color in 1 of them, because I've got 1 out of 8. Now if we imagine adding these together, we've got 3 pieces here, we've got 1 piece here, and they're all the same size, right? If you notice the bottom here is the same, it's cut into the same number of pieces, which means that each piece is the same size. So if we know that each denominator is the same, so each piece is the same size, then we can add these pieces together. We've got 3 pieces over here, 1 piece over here. That means we have a total of 4 pieces afterwards. So we've got 4 out of 8 total pieces, so our answer would be 4 over 8. What if we do a subtraction instead? Let's take the same problem, but instead of plus, we'll use minus. We've got the same 3 pieces to start with, but now we're taking away one of these pieces, which means at the end, we only have 2 of the 8 pieces shaded in, so this would be equal to 2 over 8. Looking at these, we can notice a pattern from our first example and our second example. What we can see from our examples here is that when we're adding or subtracting our fractions, what we're doing is really adding or subtracting these top numbers. So in our first case, 3 plus 1 gave us 4. In our second case, 3 minus 1 gave us 2. So we're adding or subtracting the numerators for our fractions. But for our denominators, they're staying the same. We're not adding or subtracting the denominators. Now the reason why that is the denominator tells us how big each of these pieces are. And when we're adding or subtracting, we're not changing the size of the pieces, we're just changing how many of them there are. So we add or subtract the numerators, which tell us the number of pieces. We keep the denominators the same. So if we had an example like 4 over 7 minus 2 over 7, notice our denominators are the same. Those are going to stay the same when we subtract them. And what we're going to do is subtract the numerator. 4 minus 2, so our answer is 2 over 7. Before we move on, let's take a look at some of these fractions that we got as our answers for the examples above here. Now you'll notice, if I've got 4 of these 8 pieces shaded in, this looks really similar to a fraction diagram using a circle, where I just shade in half of it and leave the other half blank. If we were to write this as a fraction, this would just be 1 over 2. 1 shaded piece, 2 total pieces. For our second one here, this one looks a lot like if we just had 4 pieces and we just shade in this top corner here. That would be 1 over 4. And in fact, because the areas are the same, these fractions must be the same. So these fractions are equivalent. Now, how would we go between these fractions? How do we know that they're equivalent? Well, one way that we can check is if I can divide the top by a number. Let's say I can divide the top by 4, so now 4 goes to 1, and I can divide the bottom by the same number, 8 divided by 4 equals 2, then these two fractions are equivalent. The same is true in reverse. So if I started with a fraction like this, and I can multiply by a number on the top and the bottom, so if I multiply the top by 2 and multiply the bottom by 2 as well, this would also be an equivalent fraction. So the key thing to make equivalent fractions is to either multiply or divide the top by the same number. This is also what we would call reducing fractions. If we get it to the point where, like 1 over 4, where we can't divide the top and the bottom by any more numbers, basically we've made the top and the bottom as small as possible, that's what we would say is fully reduced. So a reduced fraction has the smallest numerator possible while staying equivalent. And remember, equivalent means that the two fractions are equal. So when we're reducing a fraction, we're not changing the value of the fraction, we're not changing the area, we're just changing the numerator and the denominator to make them as small as possible. So if we had an example like 15 over 18 plus 1 over 18, we remember from the first part, we have the same denominator, so our denominator is going to stay the same, and we're going to add the numerator together. The size of the pieces stays the same, so our denominator stays the same, but the number of pieces is going to increase. We're adding it together, so we would get 16 over 18. Now, however, if we were answering this in a worksheet or on a test, we want to make sure we have a reduced fraction. So now we're going to have to reduce this. And the way we would reduce this is to try and find a number that I can divide the top by and the bottom by. I'll notice that my top and my bottom are even numbers. That means that I can divide the top by 2 and I can divide the bottom by 2, which would give us an equivalent fraction of 8 over 9. Now I can see if there's anything that they share here. Well, I know that 8, I can divide it by 2, but I can't divide 9 by 2. I can divide 8 by 4, but I can't divide 9 by 4. So there's nothing more to reduce, and this would be our final answer. All right, let's check your understanding. We've got 3 questions on the screen here. Grab a piece of paper, try them out for yourself, and see if you can get them correct. Pause the video, then we'll go over the answers in just a second. All done? All right, let's go over the first one here. Now the first one, we want to find an equivalent fraction. So that means that our fractions have to be the same. If the fractions are the same, that means that whatever I do on the bottom here, either multiplying or dividing, I would need to do to the top. Notice on the bottom here, when 4 goes to 24, that happens when we multiply by 6. So I would have to do the same thing to the top, multiply by 6, and I would get 18. For our second one here, we're adding 2 fractions. Our denominators are the same. We can add the numerators together. So in this case, it would be 7 plus 3 over 12, which is 10 over 12. Now we can look to reduce this. We can divide the top by 2 and the bottom by 2, and we can get our answer of 5 over 6. For our last question here, now we're subtracting. Again, our denominator stays the same as 20. We're subtracting the numerator, 15 minus 7, which would give us an answer of 8 over 20. Now we can see if we can reduce this. We've got 2 even numbers again, so I can divide the top and bottom by 2, which would give us 4 over 10. But my numbers are still even, so I can divide these one more time. Get 2 over 5, and at this point I can't reduce it any further, and that would be our final answer. That's the end of our video here. Stay tuned for part 2, where we're going to go over some multiplying questions, as well as how we can draw out multiplying fractions. See you then.